In this video, you will learn how to divide a number by a decimal and how to estimate the quotient of two numbers. So beginning with our first objective, we will learn how to divide a number by a decimal. And the process for doing that is when you're dividing by a decimal, you need to make sure that there's no decimal in the denominator. So what we do is we multiply both the dividend and divisor, so both numbers, by some power of 10 that makes the divisor or denominator of a fraction into a whole number. So let's look at some examples here. Example 1, we have 18 divided by 0.6. So if you think of it like this, we do not want this divisor to have a decimal. If you think of it as a fraction, 8 divided by 0.6, we do not want the denominator to have a decimal. Either way, it has the same effect, where to get rid of the decimal in the bottom, or in the divisor, we need to multiply by some power of 10. Well, the power of 10 we want to multiply by is going to be the power of 10 that will move it over one place. If we move it over one place, that gives us 6 down here. And so to make that happen, you multiply by 10, right? 10 has 1 0 at the end of the number, so that moves over the decimal point one place. And we do the same thing on the dividend and the divisor. So multiply 18 by 10 as well, which has the effect of moving the decimal point over one place up here. So basically move the decimal point one place to the right on both numbers to get 180 and 6. And when you do that, 180 divided by 6, this would give you 30. So our final answer is going to be 30. Let's try another example. Example 2, we have 12 divided by 0.4. Again, this divisor right here cannot have a decimal in it. So I must multiply both the 12 and the 0.4 by some number. So I need to multiply, in this case, again by a 10, because when you multiply by 10, that has the effect of moving the decimal point over one place, which puts it at the end of the 4 to get just 4. And multiply 12 by 10 as well, which moves the decimal point over one place to the right, and that gives us 120. So we now do 120 divided by 4, which would give 30 as the solution. Let's try another example. Here we now have 153 divided by 0.03. So for this one, we now have 2 digits after the decimal point. So what we must do is again multiply both numbers by some power of 10 to remove the decimal in this number, in the divisor. All right, so to do that, we needed to move over 2 places. So we had to multiply by 100 to make that happen, because 100 has 2 zeros after it. So you do the same thing with 153, multiply by 100, and that has, again, the effect of moving the decimal point over 2 places, which means we have to add 2 zeros at the end, which gives us 15300, which is 15,300. So now we can divide 15,300 divided by 3. This one, if you cannot do in your head, you can go through the process. 3 goes into 15 5 times. 5 times 3 is 15. Subtract, we get 0. Bring down the 3 and repeat. 3 goes into 3 one time. 1 times 3 is 3. Subtract, and we get 0. And then we have 2 zeros at the end here, which means we can just basically add 2 zeros at the end to get 5,100. All right, so your answer would be 5,100. Okay, let's try another example. Example 4. Now we have 3 digits after the decimal point in the divisor. So again, same thought process. We must multiply both numbers by some power of 10 to move this decimal point after the 3. So to do that, our decimal point needs to move over 1, 2, 3 places, which means we're multiplying by 1,000, because 1,000 has 3 zeros at the end, and that's the number of places we must move the decimal point. So we must also multiply 8.34 by 1,000. And so to do that, it has the effect of moving the point over 3 places to the right, which means we must add a 0 at the end, and we're going to get 8,340 and then divide by 3. So now we can divide like normal. 8,340 divide by 3. So 3 goes into 8 2 times. 2 times 3 is 6. Subtract and we get 2. Bring down the 3 and repeat. 3 goes into 23 7 times. 7 times 3 is 21. Subtract and we get 2. Bring down the 4 and repeat. 3 goes into 24 8 times. 8 times 3 is 24. Subtract and we get 0. And then we have another 0 here at the end. So 3 goes into 0 0 times. 0 times 3 is 0. Subtract and we get 0. So our solution is going to be 2,780, which is what we have right here. One more example. We have example 5. And here we are told to divide 12.1 by 0.11. So this one we're showing because it looks different than the other examples, but it's the same effect, because if you see a fraction like this fraction bar means to divide. So we're dividing 12.1 by 0.11. So what we must do is get rid of the decimal in the denominator, and so we need to move it over 2 places to the right, which means we're multiplying by 100, right? Because 100 has 2 zeros after, which is the number of places our point is moving. And then do the same thing on the top. Move it over 2 places, 1, 2, and we're going to get 1,210 on the top, and then 11 on the bottom. Now from here, we can divide like normal. When you divide, 11 goes into 12 one time. 1 times 11 is 11. Subtract, we get 1. Bring down the 1 and repeat. 11 goes into 11 one time. 1 times 11 is 11. Subtract, and we get 0. Bring down the 0 and repeat. 11 goes into 0 0 times. 0 times 11 is 0. Subtract, and we get 0. So our solution is going to be 110. So we have shown you 5 different examples where we need to divide by a decimal. And I want to also show you quickly the behind the scenes of why this process works. So here, looking at this example, 12.1 divided by 0.11, we've learned in the past that we can multiply by the number 1 without changing the value of the number we're multiplying with. So that's really what we're doing when we multiply by 100 on the top and on the bottom. Because when we do that, that's how we got the 1210 over 11. But that works because here, 100 over 100 is a fancy way of writing 1. So basically we're multiplying by 1, which does not change the original value. All it does for us is it changes the way it looks, which makes it into a problem that we can now work with. So that's the behind the scenes of why this process works. Now switching gears to estimating. So we've worked with estimating with addition, subtraction, and multiplication, and the process is really the same for dividing. Remember, quotient is our fancy word for the answer of a division problem. So if you're trying to estimate the answer to a division problem, your process is you want to round the divisor to the greatest place and then divide. So it involves rounding and then dividing. So here is example 1. We have 830.5 divided by 18. So all we do is we can round each of these numbers, 830.5, and we can round the 8 by looking at the 3. 3 is smaller than 5, so the 8 would stay as an 8, and that would round to 800. And then the 18, we can round this 1 by looking at the number after it, which would be the 8. And because 8 is 5 or bigger, this 1 would round up to a 2. So what we have is 800 divided by 20. And when you divide like this, we can do this quickly in our heads. It might be helpful if you think of this as a fraction, 800 over 20, because the zeros would cancel out right here by dividing top and bottom by 10. So you're left with 80 over 2, and 80 divided by 2 is 40. So our estimated answer would be 40. And we see that typed up right here. And if we actually were to divide those two numbers, the actual answer would be 46.14. So notice we were pretty close with our estimation. Now let's take a look at example 2. So same idea. Here we have 2,796.4 divided by 28.7. So to begin, we can round each of these numbers to the greatest place. So this 2 we can round by looking at the 7. And the 7 is 5 or bigger, so the 2 would round up to a 3. So this would round to 3,000. And then 28.7, we can round the 2 by looking at the 8. And the 8 is 5 or bigger, which means the 2 would round up to a 3. That would give us 30. So we have 3,000 divided by 30, and it may be helpful again to think of as a fraction, because we can see maybe more easily that the zeros would cancel by dividing top and bottom by 10. So what we have is 300 divided by 3, which would be 100. So our estimated answer is 100. And we see that typed up right here. And if we were to divide those numbers, so the actual numbers, our actual answer would be 97.44. So notice that our solution was pretty close to our estimated answer. Let's take a look at two more examples. Example 3, we have 8,786.32 divided by 43.1. So again, when we divide and we're estimating, we can round this 8 first by looking at the 7 right before it. And the 7 is 5 or bigger, which means the 8 would round up to a 9. So that gives us 9,000. And then 43.1, this 4, can round by looking at the 3. And because the 3 is less than 5, we would round it and keep it at 40. So we have 9,000 divided by 40. And this one is going to be a little more time-consuming to do. If you think of it as a fraction again, we can divide quick by 10 on the top and bottom to get 900 divided by 4. So when you divide by 4, 4 goes into 9 2 times. 2 times 4 is 8. Subtract and we get 1. Bring down the 0 and repeat. 4 goes into 10 2 times. 2 times 4 is 8. Subtract and we get 2. Bring down the 0 and repeat. 4 goes into 25 times. 5 times 4 is 20. Subtract and we get 0. So our estimated answer would be 225, and the actual answer is 203.9. So notice that our estimated answer is pretty close to the actual answer. Let's take a look at one more example. Here we have 333.7 divided by 16. So again, we can round both numbers, and 337, we can round the 3 by looking at this 3. And because that 3 is less than 5, that 3 would remain as a 3, and that would give us 300. And then 16, we can round the 1 by looking at the 6. 6 is 5 or bigger, which means the 1 can round up to a 2, so that would give us 20. So we have 300 divided by 20. And again, it may be helpful if you think of this as a fraction, because we can see here more easily that we can divide top and bottom by 10 to get those gone. That would give us 30 over 2. And 30 divided by 2 is pretty quick. We know that would be 15. So our estimated answer is 15, and our actual answer would have been 20.86. So again, we were pretty close to the actual answer. And that concludes our lesson for today. We will see you next time.